Welcome back. Today we're going to talk about rational functions and asymptotes. And what we're looking at today is, what is a rational function? Well, a rational function we have studied before. A rational function is where we have something f of x, so a function f of x, that's a fraction that has a function on top and a function on bottom. And the way that we look at this is we would label them just two different functions. So it'd be like nx over dx. So for example, we could have something like, oh, I don't know, 2x over 3x squared plus 1. It's a rational function because it has a function on top and a function on bottom, remembering, of course, that a single number could be considered a function. And so what we're looking at with these horizontal and these vertical asymptotes are places where the graph has certain behavior. And so with vertical and horizontal asymptotes, as we can see in this graph right here, the asymptotes are where the graph kind of runs all the way up to but doesn't quite get to. So in this case, when we have a look at this graph, this would be an asymptote, so our y-axis, or x equals 0, and also our x-axis, or y equals 0, are my asymptotes here. Okay, so there's a mathematical way to look at this, and it has to do with the number that the graph is approaching. And so for a vertical asymptote, the line x equals a, okay? That's an up and down line because it's vertical, so it's an x equals line, is a vertical asymptote if f of x, meaning the values of my graph, are going to infinity, or f of x is going to negative infinity. So it's about where the values are going. So for example, if we look at this x equals 0 line, my f of x here is going to infinity right there. So on this side, f of x is going to negative infinity, and that's what makes that asymptote exist right there. Okay, so my values are running to infinity as it gets closer and closer to that value. A horizontal asymptote is the line y equals b, so some side-to-side value, f of x is going toward b. So for example, this graph is going toward 0 as x goes to infinity, or negative x goes to negative infinity. Oh, sorry, or as x goes to infinity. I'm sorry. So as x goes to infinity, or as x goes to negative infinity. So what you can see here is that as my x goes to infinity, meaning my x values, these 0, 1, 2, 3, 4, 5, 6, so on and so forth, it's going toward this 0, and it would get closer and closer and closer, but not get there. As x goes to negative infinity, it's getting closer and closer to that value. So that's the conceptual asymptote definition. That's what conceptually it means, okay? And so what does this look like when we're trying to find asymptotes? And let me try to make this screen a little bit bigger for us. There's a couple of steps when finding asymptotes that are going to help us out. First of all, we need to look at the notation for this f of x. Well, if I've got a function on top and a function on bottom, they're going to look a certain way. Okay, so they're going to be like an x squared or a 3x squared or a negative 8x cubed, something like that. And so the general way to write this would be like some coefficient a with n, and this is just naming the number of the coefficient, so like the first coefficient, and then it's x to some nth power. Okay, and as we go down the line, what you're going to see is my next coefficient, meaning my coefficient n minus 1, meaning first one and then my next one, and then it's going to be x to the n minus 1. Well, this would be like, for example, like 3x squared plus 2x, because my coefficients and my exponents, so my exponent goes down 1, so this is like x to the first. So this function is basically being put in standard form. So you're saying, it's 3x squared plus x plus 1. Okay, so this is just a way to write it so that we can keep track of our coefficients. And on the bottom, we're just going to use b's because it's going to help us keep track of everything and we're differentiating. So in this case, like on top you might have 3x squared plus 2x to the first, while on bottom you might have 4x to the fifth minus 5x to the third. And so my exponents and my coefficients down here are going to decrease, and this is just a way to write them. Okay, and so we remember from doing long division, we have to keep track of every single exponent. Or when we were doing synthetic division, even if I have an x to the fifth here, there is an x to the fourth term in here. It's just 0x to the fourth. And so that's what this means. I go m and then I go m minus 1. So my first one is fifth and this one will be fourth. And it goes so on and so forth down the line until we have a to the x and then plus a0 with no x. And then down here we'd have b1 of x plus b0. So these are my constants on this end. And so why do we need to even bother ourselves with this? Well, what's happening is we're looking at the coefficients and the exponents to tell us where the asymptotes are going to be. And so number one, the graph, I'm going to write this in red, the graph has vertical asymptotes where d of x is equal to 0. Think about that for a minute. D of x is on the bottom. This is what we've been looking at with domain all this time. Well, the graph, and if you look here, this graph can't exist at 0. Like this graph is actually 1 over x. Well, x can't be 0. And so there's an asymptote there because there can't be a value there. And that's good because if I can't divide by 0, then there shouldn't be anything there. Okay? So that's the first one. So a vertical asymptote is where the bottom is equal to 0. That's the simpler thing to look at. So that's how I'm going to find my vertical asymptotes. My horizontal asymptotes, there's a couple of cases. The graph has horizontal asymptotes. A, if n is less than m. Okay, so I'm looking up here. N is less than m. So for example, like a x squared over x to the third. Okay, so n is less than m. Then the line y equals 0 is an asymptote. Okay, so for example, this would be n, this would be m. So we're looking at the coefficient, no, sorry, the exponent, the lead exponent at the top, the highest degree exponent on top, and the highest degree exponent on bottom. Then it has y equals 0 as an asymptote. So that's a horizontal asymptote. Another case, because they're not, those exponents, we're going to compare them. If the top one's less than the bottom, it's x, it's y equals 0. Well, if they're equal, if n is equal to m. So for example, an x to the fourth over an x to the fourth, or like 2x to the fourth over 3x to the fourth. So if they're equal, okay, the graph has an asymptote at the line y equals an over bm. So for example, an over bm, so that's the lead coefficients So it's got a line at the lead coefficients. All right, and so there's a horizontal asymptote at that line y equals an over bm. So we're going to take the coefficients and make them into a division problem, and that number that you get when you put them over each other is going to be where the asymptote is. The other case, so that's if they're equal. And so if n is greater than m, so this would be the case where you'd have like x to the third over x squared, okay? Then the graph has no horizontal asymptote. Okay, so if the top degree is greater than the bottom degree, no horizontal asymptote. That's the basic gist. So let's look at a couple of problems. So there's really 4 things you need to look at. And so I'm going to give you 2 functions here. We're going to do them one at a time, and we're going to look at what the asymptotes are going to be. The first one is a, and my function is f of x equals 2x over 3x squared plus 1. And so immediately we're going to start to look at what's going on here. So the degree of the numerator, okay, so the degree of the numerator is greater than, the degree of the numerator is less than the degree of the denominator. So that means, okay, so 1 is less than 2. So that means y equals 0 is an asymptote. Okay, so I strictly compared the degrees of the lead term. 1 is less than 2. So it has y equals 0 as an asymptote. Okay, and my vertical asymptote, so that's horizontal. Okay, y equals 0 has to be a horizontal line, but just to clarify, horizontal. As far as vertical asymptotes are concerned, we need to look at the denominator. And we're going to set 3x squared, and I'll just tell you what I'm doing up here. Set denominator equal to 0. And that's going to, whatever number comes out is going to be what my vertical asymptote is. So 3x squared plus 1 equals 0. So I subtract 1. So 3x squared is equal to minus 1. So I divide by 3, divide by 3. So x squared is equal to negative 1/3. Well, what happens is if I was going to take the square root, and this should be equal to, my pen was glitching out there, sorry. If I take the square root, it's an imaginary number. So there's no vertical asymptote. So there's no vertical asymptote because that is going to end up being an imaginary number when I set the denominator equal to 0. Okay, so this one only has 1, and it's at y equals 0. Okay, now let's do a second one. Second example, f of x is equal to 2x squared over x squared minus 1. So n is equal to m, which means that there's an asymptote at 2 over 1, and these are the lead coefficients. Okay, so I took the lead coefficient from the top and I put it here. I took the lead coefficient of the bottom, which is 1, and I put it here. So y equals 2 is a horizontal asymptote. Okay, that's pretty straightforward. We compared the degrees of that lead term. Top was bigger than bottom, so it goes, or top was equal to bottom, so it goes top over bottom. Horizontal asymptotes. We're going to look at what makes the bottom 0. So what makes x squared minus 1 equals 0? So let's solve it. X squared minus 1 equals 0. X squared equals 1. So x is equal to plus or minus 1. Okay, so there's two asymptotes horizontally. So it's x equals 1 and x equals negative 1. So my answer for this is find all horizontal and vertical asymptotes. Here's one. And here are two more. So this one has 3 asymptotes. Okay? That's how you do it. So if you follow those steps, you work on comparing the degrees of the lead terms, and then you work on what makes the denominator 0. That's how you determine your asymptotes. Thanks for watching, guys, and we'll see you next time.